So arithmetic sequences, that's a sequence that we can take and write out that has a specific difference of an exact number. So from 2 to 4 to 6, I have a difference of just 2. That would be an arithmetic sequence.
Right, it's a sequence where you add the same thing or subtract the same thing.
Right.
Yeah.
Yep.
Now, you may try to pronounce this as arithmetic whenever you're doing this, but if it is paired with sequence, we typically say arithmetic or something like that.
Arithmetic.
Which is weird. English. Psh. So we call that constant we're adding by the common difference, and we can, anytime we have one of these, we can define it recursively by saying that it's the a n minus 1 plus whatever the common difference is.
Right.
You'd have to know the first term, like you'd have to have like an a of 1 equals something.
We would need to know.
Something.
Yeah, we got to have a starter.
And then you'd be able to find every other sequence after that. So this has 4 parts on this question, and we're doing number 1. So for 1, part A, we want to find the common difference. So how much are we adding to get to the next term?
Or subtracting. Like, what are we doing, either adding or subtracting, to go from -6 to -2?
Right.
In this case, it's 4.
Right. So D is 4. And really, you need to think of it like, what are we adding each time? Because if you are really subtracting, you need to put the negative in the common difference.
And one way to find this is take where you're stopping and subtract where you're starting. So -2 minus -6
gives you positive 4.
and it'll tell you exactly what D should be.
Right. So I kind of am frustrated about the order of these numbers because I don't want to have to find the 10th term right now. I would rather write a rule and then use the rules.
Yeah.
So let's write the rules first.
Okay.
So part C, a recursive rule, we would have to say, well, our first term is -6.
Right.
And every term after that we can get by plugging in what we already know, which is a of n minus 1, and we're going to add 4 to whatever it is. That's going to give us our next term. So that's our recursive formula.
There's the recursive rule right there.
D, the explicit rule.
Which is the one that tends to be most handy, but not all the time.
Right. So if we plug in, or like we're changing by 4 each time, so we're going to have like a 4 in. And this is like what the one we did earlier, actually. So we're trying to figure out what to put here so that if I plug in 1, I want to get -6.
Right.
Okay, so what am I going to add here so that when I plug in a 1, I get -6? Well, 4 times 1 is 4. I'd subtract it over, and I'd get -10.
Yep.
Okay, so let's try that. If I plug in 1, I get 4 times 1 is 4, minus 10 is -6.
Yep,
so
that looks good.
I just was using that to help me. Now that I know that,
where'd that bug come from?
I don't know. What's my lunch? Now we can go back to B and plug in to find the 10th term. So
So then now that n then is 10 in this case. So
4 times 10 minus 10.
Right.
So that's 40 minus 10, which is 30.
30, which should work.
Yep.
Yeah.
All right, so on our second one, now this looks a little tricky.
Tricky indeed. I feel like we're going natural log 3, natural log 6, natural log 12.
So what are we adding to each one? So on your grab your calculator, and let's do the natural log of 6 minus the natural log of 3. You might be inclined to say, oh, the common difference is 3, but no, it's probably not. It could be.
Hold on it. Natural log of 6, natural log of 6.
Natural log of 6
minus natural log of 3.
Okay. Now do the natural log of 12 minus the natural log of 6.
Natural
and let's see if we get the
log
same
of
thing.
12.
We should get the same thing, otherwise this is very poorly planned on their part.
Natural log of 6. Hey, it gave us the same exact thing.
And let's think about this for just a moment. We did logarithms. Have we done logarithms?
Yeah, we did
logarithms.
Yeah, we did logarithms.
So you just did natural log of 6 minus natural log of 3 in your calculator.
Wait a second. That's like dividing 6 and 3.
Yeah, you can combine that to this. So what you just got on your calculator should equal natural log of 2.
Whoa! I'm going to punch in natural log of 2.
Okay, let's see.
It's the same thing.
Okay, so even though our
That
numbers are being
fancy.
multiplied by 2, we are actually adding the natural log of 2 each time. So D is natural log of 2. All right, so we'll come back to B a little bit later on. C, our first term is ln of 3.
Yep.
And then every term after that we get by using our previous term
Plus natural log
plus
2.
natural log of 2.
Well, good luck with part D, because I think it's impossible.
Oh, ye of little effort. Okay, so explicit rule. So we are trying to add natural log of 2 each time. So we're going to have perhaps a natural log of 2 times n situation. We want to know, what does this have to be so that our first term, when we plug in 1, equals the natural log of 3. Okay?
So natural log of 3 divided by natural log of 2, I suspect.
Okay, plug it in.
So natural log of 3 divided by natural log of 2 on tray 1.5849. That's what is that?
Well, I was thinking, okay, we just did natural log of 3 over natural log of 2. That's the change of base formula, right? So that's really log base 2 of 3.
What?
Isn't that great?
You're-
That's a tough problem. So you would have to do
a genius
Thank
today.
you. Natural
are
log
in
of 2.
fuego.
Times n, and if you add that to log base 2 of 3, that is our explicit rule.
Whoa.
Now, using the decimals in both of these cases, like the decimal for ln2 and the decimal down here, I mean, it'd get the job done.
Yeah, but you want to carry through several decimal places because natural log changes and regular log, they change so slowly. You want at least 4 or 5 decimal places while you're working this guy out.
Right, so now let's go back to B and plug in 10. So we want to do natural log of 2 times 10 plus log base 2 of 3. Go for it.
Yeah, but I feel like you're gonna like pull some cool trick out and we're gonna have like natural log of something. If I'll just do it.
I mean, I can get a
Natural
little
log
closer,
of
but
2
the bases won't match. Like, you could make this be 2 to the 10th, which
plus-
is, I don't even know.
That's a big number.
It's a bit, yeah. 2 to the 6th
Log.
is 64.
2, 3. I got 8.516.
That sounds like a great answer.
Okay.
8.516.